Okay, let's continue of functions and their graph. And we're going to concentrate on section 1.3. We're going to talk about linear equations in two variables. Basically, linear equation in two variable. Graphically speaking, we're talking about straight line. A straight line is the most fundamental graph of any equation. And let's take a look at learning objectives. First of all, we're going to use slope to graph linear equation in two variables, and we'll learn how to find the slope of the line given two points on the line. And we're going to learn how to write a linear equation in two variables. Then we use slope to identify parallel perpendicular lines, and we'll take a look at some real-life problems and how to solve them using the linear model. So first of all, slope is a very important element for any linear equation. Slope is m. The simplest mathematical model for relating to variables linear equation, we know that. And here we are using this basic model y equal mx plus b. Okay, in this given model, we are given a slope m. And we're given a y-intercept b. And the graph of this particular linear equation in two variables is a straight line. And we're going to take a look at how we construct a straight line from a linear equation in a bit. So if you're setting x equal to 0 here, then you see that y value equal to b. And this b is what we call the y-intercept. So y equal to b is y-intercept. And graphically speaking, if you look at the slope, the way how we interpret slope is when the x value go up by 1 unit, then if the slope is positive, then the y value will go up m units. Okay, here. That's how we interpret the slope on a graph. And when the slope is negative, meaning it's decreasing line, so this is increasing line. Right is meaning increasing line. When the slope is negative, that is decreasing line, line force. So end up with a decreasing line. So anytime when x value go up by 1 unit, then the y value will go down m units. Okay, so they move in the opposite direction when the slope is negative. Okay, so the y-intercept is 0b, slope is m. That's how we break down the slope intercept form. We call this slope intercept form. Slope intercept form of linear equation. So linear equation written in slope intercept form has the form y equal mx plus b. Here m is the slope and b is y-intercept. Okay. Now let's take a look at one special type of lines called vertical line. Vertical line usually has the equation in the form of x equal to a. And if you look at y-axis, the equation to represent the y-axis is x equals 0. Okay, so any parallel line to that we have a similar form of the equation. So for this line will be x equal to 1, and this line will be x equal to 3. That's labeled in the graph. So x equal to AA is a constant representing the vertical line. And now let's take a look at how we sketch a graph of each linear equation. First one is y equal to 2x plus 1. So we're going to use slope and y-intercept to graph this. Okay. So first of all, first equation is y equal to 2x plus 1. So the y-intercept is 1. B equal to 1. So y-intercept is 0, 1. And next thing, first of all, you nail down the y-intercept on the graph. Okay, that's the first point. Now you take a look at slope. Slope is equal to 2. Then turn into a fraction 2 over 1. And slope represents rise over run. We also say that vertical change over horizontal change. So positive 2 on top, meaning we will go up 2 units. And then positive 1 denominator indicates we'll go to the right 1 unit. So from there we go up 2 units and then go to the right 1 unit. Now we end up with another point on a graph, and then you're just connecting those 2 points, extending in both directions. Okay, then that's how we get the line. Very neat process to get to graph the straight line, in this slope-intercept form. Again, so this is crucial here. Rise over run, that's important concept. Okay, so second equation is y equal to 2. As you can see, there's no variable x here, so we can write it as 0x plus 2. So here slope equal to 0, and y-intercept equal to 2. Similarly, we'll start with the y-intercept. Y-intercept is 2 right here. Slope equal to 0, meaning it doesn't go up or down, so it remains flat. And that's why we have a horizontal line, right? Slope equal to 0, indicating it doesn't go up or down, it remains flat. Remain constant. Okay, so remain flat, we get a horizontal line. Now again, it's a special type of line. If you look at the x-axis, the equation representing x-axis is y equals 0. And y equal to 2 has the same format as y equal to 0, and that's why they are parallel lines. So all the horizontal lines are parallel to the x-axis. So when slope equals 0, the line is horizontal. The last one is x plus y equal to 2, so actually we can isolate y by itself by subtracting x from both sides of the equation. Then we come up with this y equal to negative x plus 2. So right here we know the y-intercept is 2, so we start with the 2. Y-intercept the 2 right here. Now the slope, since it's negative 1, so you're going to write it as a fraction, negative 1 over 1. Again, by using the general principle rise over run, negative 1 indicates go down 1 unit. And then go to the right 1 unit. So if you go, make the line go down 1 unit, stops here, and then go to the right 1 unit. And again, we come up with another order pair, which is 1, 1. And now in connecting those 2 points determines the line. And then extending both direction, you get a line. That's exactly how we graph it, using the slope and the y-intercept. And the important thing is interpreting the slope in terms of vertical change and horizontal change. And if you want to find the slope of a line given 2 points, okay, given 2 points, you could do that. So given the equation of the line, and supposing you want to find the slope of a line passing through x1, y1, x2, y2, like what the graph shows. Now basically, we know that slope equal to vertical change, slope m. Vertical change over horizontal change. And vertical change could be captured using y2 minus y1. So right here, right? The difference between those two vertical coordinates. So y2 minus y1. And the horizontal change is difference between those two x coordinates. So x2 minus x1 using bigger x value minus smaller x value. And that's how we come up with the slope formula. So y2 minus y1 is vertical change. We also call that rise. And then x2 minus x1, that's horizontal change. We call that run. So slope is basically rise over run. So slope is ratio of rise, change in y over change in x. Also we call that rise over run. So you can also do the change meaning delta y over delta x. Change in y. That's how you put into the mathematical symbol. And slope of a line passing through 2 points, given 2 points, the coordinate of those 2 points, the slope equal to y2 minus y1 over x2 minus x1. This is equivalent to y1 minus y2 over x1 minus x2. Because we could basically factor out negative 1 for both top and bottom, and cancel negative 1 and get the alternative form of the slope. Okay, so that's exactly what I'm talking about right here. If we can factor out negative 1 in the front, so we end up with y1 minus y2 on top, and factor out negative 1, it becomes x1 minus x2. So if you cancel the negative 1, both top and bottom, and get another form. So it equals y1 minus y2 over x1 over x2. But you have to change the order on both top and bottom. You cannot just change the order on the bottom and leaving the top as it is. Then this is not equivalent. So this is incorrect formula. So just pay attention to this algebra transformation. So now, for example, if you want to find the slope passing through these 2 points, 3, 4, and 5, 7, we label this x1, y1, this is x2, y2, so slope equal to y2 is 7 minus 4 over 5 minus 3, so that turned out to be 3 over 2. If you reverse the order, right, if you're using slope equal to y1 minus y2 over x1 minus x2. You get a 4 minus 7 over 3 minus 5. And they both become negative. So negative 3 over negative 2. That turned out to be 3 over 2. Same results. So no difference. Right? So reversing the subtraction orders in both the numerator and denominator. Right. So now next thing, let's find the slope of the line passing through each pair of points. First, we setting x1 negative 2, y1 0, x2 2, x2 equal 3, y2 equal to 1. So using slope formula, y2 minus y1 over x2 minus x1 So we're throwing all the numbers into the formula. Then it will be 1 minus 0 over 3 minus negative 2. Okay, that turned out to be 1 over 3 plus 2, which is 5. This is 1/5. So we are given the 2 points connecting, the slope equal to, so vertical changes 1 unit. Okay. Horizontal changes 5 units. Okay, so vertical change over horizontal change is 1 over 5. You can easily find it from the graph. So similarly, we have 2 points here, x1, y1, x2, y2. Very similar, slope equal to y2 minus y1 over x2 minus x1. So we're throwing out the numbers one more time. So it's 2 minus 2 on top, and 2 minus negative 1 on the bottom. 2 minus 2, 0. 2 minus negative 1 is 2 plus 1. 2 negative turn into positive. So it's 0 over 3. That turned out to be 0. So 0 slope meaning it's a horizontal line. So if you look at the y value, must be equal to 2. Right? So you can say that this is y equal to 2. Slope equals 0 meaning it's remain flat or remain constant from left to right. Okay. The third one, we get that x1 0, y1 4, x2 1, and y2 is negative 1. One more time, slope equal to y2 minus y1 over x2 minus x1. Throw in the numbers, negative 1 minus 4 over 1 minus 0. So this turned out to be negative 5 over 1. So slope is negative 5. Okay. And negative 5, this is, so y-intercept is 4, right? So we go down 5 units. Vertical change 5 units, go down 5 units, stop at negative 1, and then go to the right 1 unit, get a second point, connect them, we'll get a graph of this particular line. It's a decreasing line because slope is negative. So one last scenario is we call it vertical line. So here we are given x1, y1, x2, y2. So again, using the slope formula, y2 minus y1 over x2 minus x1. y2 is 1, y1 is 4. 1 minus 4 over 3 minus 3. 1 minus 4, that's negative 3 over 0, that's undefined. Any number over 0, undefined slope indicates it's a vertical line. Okay, vertical line for the x value must be 3. So equation will now be x equal to 3. Okay. Now if you plot those both points, you can also see that must be a vertical line. Right. A vertical line has an undefined slope. And next topic, let's look at how to write a linear equation in 2 variables. So we already know the slope-intercept form. Another popular form is called the point slope form. For example, let's say we get a given order pair x1, y1. There's a point on the line of the slope m, and another point xy. Is any other point on the line. And using slope formula, y minus y1, you can think of this as x2, y2, another point. So we're using this slope formula, come up with a y minus y1 over x minus x1 equal to m. And if you make it proportion cross multiplying, and we're going to come up with the y minus y1 equal to slope cross multiplying. m times x minus x1. And this is another popular form called point slope formula. In the point slope formula, we need two elements. First one is a slope, other one is a given point, a given order pair. So point slope formula is y minus y1 equal to slope times parenthesis x minus x1. Okay. Slope m is given, and then given point x1, y1 is given. Now, let's look at an example using the point slope form to find the equation of the line. Okay, so we given slope 3, so m equal 3. We given point x1, y1. That's -1 and -2. So x1 equal to 1. And then y1 equal to -2. So using point slope formula, y minus y1 equals slope times x minus x1. Throwing all three numbers into the formula, so y minus y1 is -2, slope 3 times x minus 1. So you get y plus 2 to -10 positive. Distribute it, you get 3x minus 3. We're going to isolate y by itself, subtract 2 from both sides of the equation, and come up the equation of the line in a slowness of 3x minus 5. Okay, so 3x minus 5 in the slowness of form, and you can easily graph it using the y-intercept be equal to 5 and a slope which is 3. So make it 3 over 1. Go up 3 units, go to the right 1 unit. So start with the y-intercept 5, get the first order pair. Now go up 3 units, 1, 2, 3, stop here and go to the right 1 unit, get second point. Now we connect it on both directions, extend it, and we get a line. Now graph the line. Alright. So the point slope form could be used to find the equation of a line passing through this point, 2 points. So we're using slope formula to find the slope. We're using point slope formula to get this form. And this is what they call a 2-point form. y minus y1 equal to y2 minus y1. So I'll put into parentheses that you could do that over x2 minus x1 times x minus x1. This is 2-point form. Next thing is the parallel lines and perpendicular lines. Two parallel lines typically will look like this. Okay, this is analogy of two parallel lines. Perpendicular lines are basically perpendicular to each other, so they form a right triangle here. Those are perpendicular lines. Okay. I'm going to look at it from using the slope. Interpret the parallel and perpendicular lines using the slope. So if two lines are parallel, two distinct non-vertical lines parallel, even if their slope are the same, so m1 equal to m2, they have the same slope. If this vertical line, then the slope is undefined, so we couldn't use slope to identify the two parallel vertical lines. And also, two non-vertical lines are perpendicular only if their slope are negative reciprocal of each other. So m1 equal to negative reciprocal of m2. Or another way of saying that is the product of their slope is equal to -1. Alternative form of the perpendicular lines. And let's use the general guideline to find the parallel and perpendicular lines. Let's say find the slope intercept form of the equation of the line that passes through the point 2, -1. And the first one is parallel to this given line 2x minus 3y equal to 5. Second one is find the perpendicular to this line. So since we're going to use slope to tackle the parallel line and the perpendicular line, so we need to identify the slope first. So we use the original equation, and then we're going to solve for y to get the slope intercept form. So the first step, subtract 2x from both sides equation. Negative 3y equal to negative 2x, adding 5. Now we will get rid of the coefficient in front of y, so dividing negative 3 across. Across the left hand side, right hand side of the equation, then simplify, then we'll be able to find out the slope. So 2 negative turn into positive, so end up with the 2/3 of x. Plus minus is minus 5/3. So in this case, we know that slope for this line is equal to 2/3. Now that's very important starting point. So now we know that slope is 2/3 shown. So first one, let's find that any line parallel to the given line that have the slope of 2/3 and passing through 2, negative 1. And we can use either formula. I'm going to use a point slope formula. Point slope form. Which is y minus y1 equal to slope times x minus x1. So the parallel line has a slope of 2/3, then so this slope must be equal to 1/3. And given point x1 is -2, y1 is -1. So y minus y1 -1 equals slope 2/3 times x minus 2. Now simplify y plus 1 on the left, distribute it, 2/3 of x, and 2/3 times -2 becomes -4/3. Now get y by itself, subtract 1 from both sides equation. 1 is equivalent to 3/3. And now the direct fractions combine them, so we get y equal to 2/3 of x minus 7/3. So this is the equation of the parallel line. Parallel line to the given equation. And the perpendicular line have the negative reciprocals, so negative reciprocal of 2/3 will be negative. First one is negative, and then reciprocal, find the flip top and bottom, you get 3/2. So slope for the perpendicular line is -3/2. Now we still know that x1 is 2, y1 is -1. So still using point slope formula, y minus y1 equals slope times x minus x1. Again, we're throwing all the numbers into the formula, so y minus -1 equal to -3/2 times x minus 2. Simplify a little bit, so we have y plus 1 so y plus 1 equal to distributed -3/2x, 2 negative turn into positive, 3/2 times 2 becomes 3. Now we subtract 1 from both sides equation, and again the equation for perpendicular line is -3/2x adding 2. We'll call this perpendicular line, equation of perpendicular line. Okay. Now let's move on to the applications. Let's look at this example on predicting sales using a linear model or linear equation. And here we're assuming the sales grows linearly. So sales for Best Buy approximately 49.7 million in 2009, 50.3 billion in 2010. Using only this information, write a linear equation. I give the sales in terms of the year and predict the sales in 2013. So first of all here, let's assume in 2000, this is the year 0. Then in 2009, and we know that this is year 9. The reason why I picked 2000 is for the convenience reason. And then 2010, that will be year 10. 2013, that's year 13. Here, this time t is what we call the independent variable or variable x. So t equals 0, t equals 9, and t equals 10, t equals 13. Very important interpretation of the information given in the question. And from there, we'll be able to come up with order pairs. So t equals 9 representing 2009, and the order pair will be time t and then sales. So 2009 will be turned into an order pair of 9, 49.7. 2010 will turn into an order pair of 10, 50.3. So here that's exactly x1, y1. This is x2, y2. That means we know this, we will be able to find the slope first. So y2 minus y1 over x2 minus x1. And this slope indicating when the time t is increased by 1 year, the sales go up by how many billion, right? So let's do that. So 50.3 minus 49.7 over 10 minus 9. Then if you find difference, it will be 0.6 over 1. So it's 0.6 billion per year. Meaning as the time goes by about 1 year, increases by 1 year, then the sales will go up by 0.6 billion. Because it's increasing, right? It's increasing through the time. So now once we have this, let's come up with the equation of the line. So using Poincare law formula to come up with the equation of the line, y minus y1 equal to slope times x minus x1. I'm just throwing out the numbers. So y minus y1 is 49.7, slope is 0.6, x minus 9. Okay, and distribute it, combine like terms. So y minus 49.7 equal to 0.6x minus 5.4. Now next step is just adding 49.7 from both side equation. Then come up the equation representing this relationship between sales and time t. So y equal to 0.6x, 49.7 minus 5.4, that's going to be 44.3. Okay. Now we come up with the equation. X here represents the time in year, and y represents sales. Okay. Then according to equation that we're using, here the time t is given as 13. That means x equals 13. So we have y equal to 0.6x plus 44.3. Here replace x with 13. So y equal to 0.6 times 13, adding 44.3. 0.6 times 13, that's 7.8. Adding 44.3. This turned out to be 52.1 billions. That means in 2013, the sales could become 52.1 billion. And if you plot all those 3 points on a line, on the Cartesian system, connecting them, you get this linear equation here. Okay. And in terms of the graph, will be a straight line. And that's how we utilize the linear equation or linear model to solve the real world problem in the business sector. And also we have another form called general form. Equation of the line could be written as ax plus by plus c equals 0. Here a, b are not both zeros, right? And so basically, summary of the equation of the line, general form, let's talk about that. Vertical line x equal to a is a constant. Horizontal line y equal to b is a constant. We have slope-intercept form y equal mx plus b. We have point slope form, and then we have 2-point form. And those are the popular forms of the linear equation.